Hello everyone, good evening. Today we are going to discuss problems that has been given in Codeforces Round 859, which is Div 4. It consists of uh, 8 questions. So the first question will be discussed by Anjani. So
Okay, so let's start with question number A. So in this question, it is pretty easy because we are given three integers and there are two equations which must satisfy. If and just suppose we have A, B, C, these three integers are given, and just suppose the first condition is satisfying such that A plus B equal to C, then we have to print plus, and if A minus B equal to C is satisfying, then we have to print minus. So let us see the code for this, which is here. So in this you can simply see that if we are going to get the first condition correct, then we have to print plus, otherwise we are going to print minus. So any doubt in question number A? Hello. So I think it is clear. So now we'll move to. So now we will move to question number B. So in this question, it is simply saying that there are two persons who are playing this game, and in this game, the player one, whose name is Mihai, it will get all the candies from the bag if there are even number of candies. Okay, and the second person, who is Bianca, she will grab the candies in the bag when number of candies is even. Okay, so let me first understand this question by the given test case. So the first test case given is this is 1, 2, 3 and 4. So what will happen? This is person A and this is the second person. Let us name it as B. So what will happen? This is means bag burn, and we have only one candy in it. So it will be given to person number B. This is even number of candy in this bag, so it will be given to person number A. This is odd number, then it will given to B, and this is even, then it will given to A. So the question says that you can shuffle means yeah. Okay. So means the question says that you can shuffle the bags such that we will try to make sure that means person A wins. Okay. So when the person A will win, it is simply at every stage. Means just suppose we make some combination from this simply 1 2 3 4. Just suppose I make a combination 1 3 4 2. So 1 3 4 2. So at this stage means when we are traversing in this. So what is this sum for A and B? So it is, since it is odd, so it will be given to B, and A has nothing, means A has 0. Then we move next to second bag, then 3 will be given to it and A has nothing. When we move to this, 4 will be given to A has nothing. So at these 2 points we are saying that B is winning at this one and at this one. But we have to make sure that we have to make the arrangement in back such that at every point A will win. Okay, so let's write another combination. So I am writing 2 1 4 3. So in this we can see just suppose this is A and this is B. When we are going at first bag, then we are saying that A has 2, B has 0. So at this point A wins. When we go to second bag, there are odd number of candies, it will be given to B, and A has 2, and at this point A again wins. When we move to third bag, 4 candies, it will be given to A, B has 1 candy, and it will become 4 plus 2 6. So here A wins. So in this way we can see that for making sure that A will win, we will have to start such that A has more number of candies at particular time. So how we can do this? So it is only possible when we have sum of all the even numbers is greater than sum of all odd numbers, because for winning A we can always write a permutation such that all even numbers comes first. Just suppose here 2 4 and after that 1 3. So we can say that at this point it is 6 and here the sum is 4. So until and unless this even sum is less than odd sum, A is going to win, and if it is less than odd sum, A can never win. So the code is like that. Okay, so let's see the code for a second. So it is pretty simple. Simply we have taken the input till here, and just suppose the element which we have taken is even, then we are going to add in an even variable, and if it is odd, then we are going to add is in odd variable. So as we have seen in the test case 1, that if the sum of even number of elements is greater than odd, then it is always possible that we are able to make that combination of elements of array. Otherwise we are never able to make that possible case. Okay, so this is in question number B. Any doubt? Hello. I hope you are able to understand this. So let's move to question number C.
Okay, so let's discuss problem number C. Okay, first of all, read the question. The question is like that: you are given a string as consisting of lowercase English letters, Latin letters. In an operation, you can take all the characters, replace all occurrences of this character with either 0 or replace all occurrences of this character with 1. Okay, so now the question asks that is it possible to perform some operation so that the resulting string is an alternating binary string? So here it is given an example to explain the question. So for example, consider the string A B A C A B A. So first of all, we replace all the occurrences of A with 0. So the string becomes like this. Okay, so in the next step, we replace all the occurrence of letter B with the 1. Okay, so the string becomes this. And in again the next step, we replace all the occurrence of C with 1. So our string becomes this. So this is an alternating binary string. So what is an alternating binary string? Here it is given that an alternating binary string is a string of zeros and ones such that no two adjacent bits are equal. For example, like 0 1 0 1 0 1 1 0 1 1 are alternating binary strings. But like here it is, this is not a alternating binary string because like it contains a 1 1 adjacent 1 1, and it is not a binary string. First of all, this one is not a binary string because like it contains letter 0, and it is not a alternating binary string because it contains two adjacent zeros. Okay, so this was the question. Let's understand through test cases.
Okay, so first test case is
So this is the given input string. So according to the question, like we can replace character A with either 0 or 1. So like to not generate let's replace A with 0. Okay, so 0, so it becomes 0 0 0 B A, and then like replace B with 1, so it becomes 0 1 0 0 1 0 0, and C with 1. So in this case it becomes a alternating binary string. So like for this the answer is yes. Okay, first this is let's take second test case. Second is A. So here whatever you choose, like either you choose A to be 0 or 1. You will getting to be like either 0 0 or 1 1. Both are not alternating binary strings. The answer for this will be no. So okay, now let's take another test case. Okay. So now basic observation here is any alternating binary string, like either it is 0 1 0 1 0 1 or it is 1 0 1 0 1 0. So the basic observation here is like the parity of zeros or the parities of 1 are same, like in every like in every string, in every alternating binary string, the parity of zeros and the parities of 1 are same. So like this is the only basic logic or basic observation you need to make. So to do this, you have to only just check that in the given input string, the parity of the same characters should always be same. Like what do you mean by parity? Like the position should be like the position is either divisible by 2 or it should be like gives the remainder 1. So every parity should be same. So either it should be like everyone should gives the remainder to be to 1, or either it should give 0. So like let us suppose, so here in this case all the a's are present. Like if it is 0, if I take the its parity is, let us assume its parity is 0, its parity is 1, its parity is 0, parity 1, parity 0, parity 1, parity 0. So all the a's are present in 0 parity, and all b's are present with 1 parity, and all c are present with 1 parity. And here like a is present with 0 parity also, and a is present with 1 parity also. So it is not possible, and it is possible. Now let's take like this case also, n I n f I a. So here n is present with 0 1 0 1 0 1. So n is present with 0 parity. Okay, so it is fine. I is present with 1 parity and 0 parity. So like it is not possible. The answer here will be no. So yeah, like this was the basic logic. Let me show you the code. So this is the code for the problem number C. So here we take the test cases and just we take the string and create like all the 26 characters. We initialize with -1 and then run a loop from 0 to n-1 and like just check for that if the position if we haven't encountered that character, which means it is -1. So like if first we encounter this, then we set the parity to like I and 1. It is basically like we end with last digit, like either it is 0 or it is 1. So yeah, like, and if we encountered second times, like it means that we have encountered first the characters, then it is not -1. So we just check the parity is same or not. If it is same, then we like move forward to the next, and otherwise we see out no, and then just return from this. Or else if we don't encounter this, we will see out as yes at the last. So yeah, like okay. So any doubt with this question? Any doubt with this question? Okay, so like let's move.
Okay, now let's solve question D. In question D, you are given an array. Am I audible? Everyone, am I audible? Yeah, okay. So, coming to question D, you are given an array of size n, and for each array you are given k queries. The queries are that the queries have 3 parameters. One is the like L, R and K. What it does is in each query you change the elements of array from index L to R to value k. So what we are doing is, suppose the given array is a1, a2 and so on an, the elements al plus 1 and so on up to ar are replaced by k. Now what the question is asking is, you are given k such queries and you have to find out whether the total sum of the array is odd after implementing this query. So I'll explain it on screen. Yeah. So the main catch here is, you cannot be solving each query in O of n time, because the number of queries are of the order 2 into 10 power 5. So solving each query in O of n time will give you time limit exceeded. So what we try to do is solve each query in O of 1 time. How can we do that? Like, we can use prefix sum to do that. Initially, like, when will what is the final sum of array? Let S be sum of all elements of array, and let alpha be sum of elements from index L to index R. Now we are replacing this alpha with k into size of this sub array, you can say. The size will be r minus l plus 1. So what we are doing is, in each query we are removing the sum alpha from S and adding k into the number of the size of sub array removed. So to solve this in O of 1 time, we can use prefix sum. What prefix sum does is, we create an array of size n plus 1. Okay, I'll explain prefix sum using a test case. So the first test case was, the number of elements were 5. The array's elements initially were 2, 2, 1, 3, 2, and the query was 2, 3, 3. So let us make prefix sum array. The prefix sum array will be of size n plus 1, and what it does is, it stores the sum of all the elements which were previous to it. Like, prefix sum of index I stores sum of elements from index 1 to index I. So initially the sum would be 0, and prefix sum array 1 would be, this would be 2, and now sum up to 2 elements would be 2 plus 2, that is 4. So you can add plus 2 here, this will be 4, and sum of first 3 elements would be plus 1, so this would be 5. And doing this way, we'll get the prefix sum array. Using prefix sum, you can calculate the sum from index L to index R in O of 1. How can you do that? Like, to calculate sum of from L to R, this would be equal to the value of prefix sum at index R plus 1 minus, like, the value of prefix sum at index L. Why we are doing it is, the sum of elements from L to R is nothing but sum of elements from 1 to rth element, and we will have to subtract the sum from 1 to L. So this is what we are doing to solve in O of 1 each query. I'll also show the code. Okay, so initially, before solving each query, what we are doing is we have formed the prefix array. This PF is nothing but prefix array, and you can easily do this using the previous index, like sum up to first I elements would be sum up to uh, first I minus 1 elements plus A of I element. This A of I is nothing but in here. Now, for solving each query, the final sum would be the total sum of array is sum up to 1 to n elements, which is nothing but PF of n. Now, what we are subtracting is sum from lth element to rth element. This, as explained, will be PF of r minus PF of l minus 1. And instead of this, we are adding k as element. So the total sum it will contribute will be k into r minus l plus 1. So finally, the sum of our array will be PF of n minus sum plus this sum 2. This sum 2 is representing k into the size of subarray LR. Now what we are checking is if this is odd, we are checking the parity, and if it's odd, we are outputting 1 else 0. Is everyone clear with prefix array? How many of you were familiar with prefix array before this problem? Like raise hands or yeah, great. Now we'll be moving to problem number E. In problem number E, for time being, let us forget that this is interactive problem, and let us try to understand what this question wants. So you are given n piles of stones, and all the stones except one has weight of 1 gram, and there is one special stone whose weight is 2 grams. So you are given n piles of stone, and you also know how many stones the ith pile has. Like AI represents the number of stones in ith pile. Now what they are asking is to find the pile in which the special stone is present. Like special stone is present in only one of the n piles, right? So you'll have to find the pile in which the special stone is present. And you have to do this in at most 30 queries. In each query, you can like ask the total weight of, like in each query, what you'll have to do is pick some of the piles. Like if you want to pick k piles, like this is an interactive problem. You'll have to interact with the judge the k piles that you have selected. So you'll have to output the k piles that you have selected, the index of the k pile. The judge will give you the sum of all the stones present in kth pile, like the k piles you have selected, and you know the number of stones in the k piles you have selected. So using this, you can tell whether the special stone is in your selection or not. So if the special stone is in your selection, the total weight returned by judge will be one more than the total number of stones, because one of them has 2 grams of weight and rest all are 1 gram. But if your pile does not have special stone, the judge will output the number of stones, the total number of stones in your selection. So what we do here is, since one way you could do this was using brute force was select all subarrays, like if n is 2 into 10 power 5, you would have 2 power n number of subarrays, 2 power n minus 1 actually. So that would easily give time limit exceeded. So you'll have to at most use 30 queries. So what you can do is you can use divide and conquer method. Initially, if you have, and using binary search, initially if you have, you know that the special stone is present in pile from 1 to n, like you pile 1, 2, 3 and so on up to n, you know that in one of them the special stone is present. Now you ask the judge, I'll explain it on the notepad. Yeah, the notepad is fine. So initially the piles were pile 1, pile 2 and so on up to pile n. You take the lower bound and upper bound of your search space. Initially your search space are all the piles. So initially your lower bound would be 0. Let us start our indexing from 0, and your upper bound of your search space will be n minus 1. Like initially you know one thing, that between the index 0 to n minus 1, one of them has the special stone. Now what you do is you take an index m which is average of these two, like L plus R by 2, and you search whether the piles from L to M have the special stone or not. In this, what you are doing is you are dividing your search space into half. How can we search whether this subarray of piles has the special stone? What you can do is you can submit these piles to the judge, and the judge will return weight of it. So if the weight is exceeding the number of elements, you know that these piles have the special stone. Else the other half would be m plus 1 to r, else this half has the special stone. So what you are doing is you are dividing your search space into 2. So if your search space was n initially, it will be divided into n by 2, then n by 4, and so on in log n steps. You can make it into 1. So how will we do that is, I'll show you the code to do this. I hope the screen is visible. So what we are doing is, initially our search space was 0 to n minus 1, and we have this middle index. We'll continue our searching until there are greater than 1 elements left. So if r minus l is greater than 0, you know that there are at least 2 elements left in our search space. So you take the middle element, that is r plus l by 2, and the size of your selection is m minus l plus 1. That is what we are doing is we are outputting the piles for the online judge. We can ignore this part for now because this is part of the interactive problem. I'll be explaining the logic now. So this weight, even here to calculate the weight in O of one time, we'll be using prefix sum, because to calculate weight from L to M in O of one time, it is similar to D problem. We've used prefix sum in the previous problem. So initially we have calculated the prefix array, then you can check the weight using the same logic. PF of upper bound minus like sum of number of stones in pile 1 to M minus sum of number of stones in pile 1 to L minus 1. So you have calculated this, and if the weight returned by the judge, this weight would be written by judge, we are taking it as an input. If this is equal to the number of stones in your selection, you know that the special stone is in other half, so you increase your lower bound to the starting index of other bound, that is m plus 1, because your first half was L to M and your second half was m plus 1 to R. So you'll change your search space from L to R to m plus 1 to R, dividing it by 2. So finally you will be left with one element, and that index would be the index of pile in which special stone is present. Like what we have done here is used binary search and divide and conquer. Is everyone like clear with this, or shall I explain it again? Feel free to like chat if you want to explain me again. Okay, since every one of you are clear with this, we'll be moving to the next question.
स्क्रीन शेयर तो चालू ही है ना. Okay, so now in the problem F, that is bouncy ball, we have given that there is a ball that is placed inside a grid. So as you can see in the question, we have an n cross m grid in which we have given the starting position of the ball and the the starting direction of the ball, which is along one of the diagonals of the grid, which is like down right, down left, up right and up left. So like in this sample we have the ball placed at 1,7 starting at down left, so it goes along this diagonal and then bounces off the wall. And so we are asked that for the ball to stop at the final position, like if it reaches the final position, so we need to output the number of bounces. So here we have in the input we have n cross m and then I1 J1, which is the starting coordinates, then I2 J2, which are the ending coordinates, like we need to reach that. Okay, so in this problem we look at the constraints. So like we have n and m less than 25,000, and also we are given that the sum of n cross m is less than 5 into 10 to the power 4. So like if we do brute force here, so it is far less than 10 to the power 8, which are the number of operations which can be done in 1 second. So like for this code we will actually simulate the ball traveling in the grid and bouncing off the ball, and at every step when it bounces we will calculate like add one to the bounce variable. So like we can understand it from the code. 1 second, I will share it. Okay, yeah. So like here you can see the code. We in the main function we are taking the number of test case and input and calling the solve function. And the solve function, the rest of the variables here are declared globally, so we can use in the other functions declarable. So we have I1 J1, I2 J2 and direction as a string. So like it, if it is already at the ending position, then there are 0 bounces. Okay, so yeah, here we have just coded down right as 0, down left as 1, up right as 2, and so on. And we start the travel here from I1 J1 starting direction 0, and now the bounce is 0 here. Like there are 0 bounces till now. And here we simulate the travel. Like if it is off the grid in index 0 or n plus 1, 0 or n plus 1, or we have already visited this position, then we should stop the travel, like we can no longer visit. And if at any point we are at the final position, ij is the current position here, then we have here f is also a global variable which stores that we have reached the final position or not. So if we reached it, then we have turned its value to 1 and printed the value of bounce. And if we have reached the final position, we simply return the function. Yeah, so in the function, the first thing is we have visited this block in the grid. And then in the first here, we check that if we are at a corner, like 1 comma 1, 1 comma, and these are the corners. So like if we are at a corner and direction 0 here means that like if we are 1 comma 1 is the top left corner and direction 0 is our down right. So like if we are going in the correct direction, then we won't bounce at the corner. So if direction is 0, then we don't need to add 1 to the bounce variable, or else it will bounce from the walls and the resulting direction will be 0, down right from the top left corner, and similarly for all the corners here. And once we are done with the corner, we check for all the 4 walls. Like if I equal to 1, it represents the upper wall of the grid, the top wall. Okay, so similarly we check for all the walls and increase the bounce variable once and change the direction accordingly. Like if we are going to the top right and hit the top wall, then we change our direction to bottom right, and similarly. And yeah, here this is actually I plus dx of direction. Here I have declared dx and dy as arrays, and direction here states this, like if direction is 0, that means we are going in positive x and positive y. Direction 1 states that positive x and negative y, and similarly. So like yeah, you can have a look at this. So any doubts, any problems here, anything you didn't understood? Okay, then I will consider you have understood everything. Let's move on to the next question.
So now let's discuss question number 7, that is G. It has 2 parts, G1 and G2. G1 is a simpler version of G problem and G2 is a difficult version. The only difference is that its constraints are restricted, that is the constraints are higher for G2, where it is lenient for G1. So in the question we are given an array A. It contains only a single number 1 Now we have to perform several operations. It can be zero operations, possibly zero operations to and afterwards we have to generate a final array C. We have to check if we can generate a final array C or not. So in the in what operation we have to perform is that you can select some subsequence. Subsequence is any if subsequence has k numbers, then we can select any k elements from the array. That is known as a subsequence, irrespective of what order they are. So after selecting a subsequence of A, we will add all the elements present in that subsequence, and we will finally add that sum to the array. This increases the array by the length of array by a single unit. So it is explained properly over here, which says that a subsequence B is a sequence B is a subsequence of a sequence A if B can be obtained from A by deleting of several possibly zero but not all elements. In another words, if we select k distinct indices I1 to ik and insert anywhere, if we select these k indices and we will select those elements from the array and then add all of them, and then we will insert it anywhere in the array A. Now we are given input as first we will given a t which is the number of test cases, and each test case will contain a single integer n and an array C which contains n elements. Now we have to check whether we will be able to generate this sequence C from the given sequence A, which contains only one element, that is number 1. I will explain you from tab. So the first of all we are given an array A which contains only one element, which is only number 1. Now we will be given some C array which is C1, C2, C3 to Cn. We have to say whether this can be generated from A by performing the set operations. Now it is a bit tricky question, but actually the truth is that we can generate any sequence of n length, provided a specific condition which I will tell later on, which is that let us say that sum be the prefix sum array of C prefix sum array of C. So if sum of I, that is sum of first I elements, is greater than or equal to the element at I plus 1th index, then we can say that this that specific sequence can be generated. Now I will explain how it came. So it is proved by using induction. Firstly, we will assume that at all arrays of length n, let's say that array B, it has n elements. Now we are saying that we can generate let me write it as b1, b2, b3 to bn. Now using any subsequence from this, we are assuming that any subsequence, if we choose some specific subsequence, we can generate any number. Let us say it as x. We are assuming that b is in sorted order. We will first sort this. Now if we choose any subsequence from now we will be saying that now what we are assuming is that we can generate any number x from 1 to sum, or you can say that sigma bi, I is equals to 1 to n. We can generate any number from 1 to sum of all elements in B by choosing some specific subsequence. It is our assumption. Now we will be using this to prove that it is true for a sequence with n plus 1 elements. We will prove this for let us say it as b dash. B dash has n plus 1 elements. Now we will prove that by assuming that for every n for a given n elements, we are given that for a given n elements we can generate any number from 1 to sum of all elements in that sequence. Now we will be proving that b dash, which has b1 dash as b1, b2 dash as b2, and so on. Now that is b dash is equal to b1, b2, b3 to bn, and another element, let us assume it as, let's say it as bn plus 1. So now we are saying that now we have to prove that we can generate any number from 1 to summation of bi from I is equals to 1 to n plus 1. Now we have to prove that this is possible by choosing some specific subsequence from the b dash array. Now to prove that, if y is less than or equal to summation of I is equals to 1 to n bi, please note that it is n, not n plus 1, case 1. For this case, we can use a subsequence from only b1 to bn, as we have already assumed it in the induction step, where we have said that we can generate any number from 1 to bi, summation of bi's from one of the array from 1 to n elements. We can generate any number. So we will use that specific subsequence, which we will be as we have assumed it in the first step. Now the second case would be, case 2 will be, y is greater than summation bi from I is equals to 1 to n, and it is less than or equal to summation bi, I is equals to 1 to n plus 1. Now for that we will select we will write y as summation I is equals to 1 to we will write yi as bn plus 1 plus some alpha. We can write it because we are assuming alpha is a specific number. Alpha will be y minus bn plus 1. Now as you can see that y is so as y is less than equals to summation bi from 1 I is equals to 1 to n plus 1, so alpha will be less than equals to summation I is equals to 1 to n bi. Using these two, we arrived here. Is this clear? Till now, is it clear? Okay. So as it is less than summation bi, so we will again use our assumption that we'll again use the statement that we have assumed, that if the sum is that we can generate any number from 1 to summation bi from I is equals to 1 to n using a subsequence from bi to bn. So let that subsequence has bi1, let that subsequence be bi1, bi2, bi3 to bik. The summation of this will generate alpha, and if we add bn plus 1, all I1 to ik are less than equals to n and greater than equals to 1. So if we add bn plus 1 to it, we can generate y. So by this we have proved that, given that if for a sequence n, if we can generate this condition, then for having n plus 1 elements, we can generate another sequence for that which will hold this condition. So now as this condition is being held, we will now use this to generate our solution. Now for actual solution of the question, we will be given a sequence c1 to cn. Now first of all, we will sort this to, let's say, d1 to dn. Now as we have said that d1 to d2, d3 to dn. Now as we have proved that by induction, that for a given sequence of let me write it, for a given sequence of n elements, we can choose a subsequence such that sum of all elements of subsequence will lie between 1 to sigma bi. That is, we can generate any every element from 1 to summation of bi by choosing a specific subsequence from a given n elements. Now applying this to our question, for so if we can say that d1, d2, d3 to dn, if d3 is less than equals to d1 plus d2, then it is greater than equals to 1, and then from this we can choose a specific subsequence from d1 and d2 which can generate d3. And then see, d1 and d2 are not constants, we can change d1 and d2 time to time. Now similarly, if one is d4 is greater than or equals to d1 plus d2 plus, if d4 is between 1 to d1 plus d2 plus d3, then we can generate a sequence d1, d2, d3, d4 which will satisfy our given conditions in the question. That is, we can choose a specific subsequence from d1, d2, d3 which will sum and give us the number d4. Similarly, moving on, so if for all di's, if we can it lies between 1 to summation d alpha, if it lies from I is equals to 1 to alpha minus 1 di's, then we can generate that subsequence. Now to solve this, now to generate that subsequence, we will first start from we have sorted d array is sorted. Now from the last, now we will start from last element, d1 to d2, d2, d3, dn. We will first generate a prefix sum, which is s1, s2 to sn. Prefix sum array. Prefix sum array. Now if di plus 1 belongs to 1 to si, then we can generate a specific then we can perform the provided operations multiple times to generate the given sequence. So I will show the code for that. Is the logic clear, or should I explain it in more detail? Hello? Understood. Fine. Great. So let me show you the code. So the code for this question is this. First of all, we are taking t, which is number of test cases, and for each test case we will input n, and we will input the array. Then we will sort the array. Then we will update AIs to be the prefix sum array, and starting from backward, we will check whether the last element, that element with difference of the prefix sum of till I elements and minus prefix sum till I minus 1 elements will lead to ith element, and this element, if this element is greater than the prefix sum just before just taking I minus 1 elements, then we will update the check to 1 and break the loop. And if also to be noted that as in the question it is given that we have to start from 1, we have to make sure that the first element has to be 1, and if it is not, then we will again mark the check as 1. If the check is 1, that is if it is not following the given conditions, then we will output no, else it will output yes, then else we will output yes. Is the code and logic clear? Hello. Okay. So if you have any doubts from any question, A, B, C, D, or E, F, any question, you can ask it now, or else we will be sharing this video. Along with that, we will be sharing our codes with you in a mail, and also in the description link of the YouTube. I hope that you all have joined our WhatsApp group. If not, please do join that. And if you have any queries later on or at any stage, you can ask us in that group, or you can also DM us.